This
session will.
conference will now be recorded.
So I started recording. Okay. So what I'll do, let me close this. Okay. So this is your first class after demo. SAP HANA. SAP HANA is primarily, it's a database, and how it is different from other databases. First of all, we need to understand, and what are all the special features we have in this database, we need to understand. We have other databases available in the market: Oracle, SQL, and you have DB6. Oracle is from Oracle Core, SQL is from Microsoft, and DB6 is from IBM. So we have these databases available in the market from last 20 to 40 years. So although we have these databases, okay, why we required a new database called SAP HANA, and these databases are used already in SAP applications. So why we required SAP HANA as another database. So whenever we use SAP applications, these are the databases we are using at this moment, and SAP doesn't want to rely on third-party databases. So SAP created their own database that is nothing but HANA. So SAP customers going forward, they're going to mount their applications on top of the HANA, and they're not going to use the traditional databases or third-party databases, which are going to cost additional licensing. And again, SAP application has to be created based on the database compatibility, and in order to get rid of that dependencies also, we are not going to, SAP doesn't want to use third-party databases. So SAP HANA primarily act as a database. What kind of new features we have in this database? And this is in-memory database. This is one of the new feature, and the other feature is it is a hybrid database. And one more feature we have, we can start doing the modeling in the database itself. What it means, you can use this database as a data warehousing solution, and you can start doing the modeling. And this database is going to store the data internally using IDs, so it will have compression by default. And this database is having some of the libraries, and using those analytical library, predictive analytical library, and business functional libraries, you can use these libraries, and you can have predictive analysis using SAP HANA DB. So all these are main features of SAP HANA. It is in-memory database, and it is hybrid database. I'm recording the session. I'm going to discuss about the compression later on. And it is having modeling features, and it is having a concept called compression by default. So the data can be compressed in the sense, using database, we are going to store the data. It is going to consume a certain memory. And if you are storing the same amount of data in the Oracle, if it is consuming some memory, and the same data, if you are storing in the HANA, then obviously it is going to consume less memory in HANA when compared to the Oracle because of a concept called compression. I'm going to discuss like what is this compression and how it is useful with respect to HANA later on. So these are main features in memory database, hybrid database, and we have modeling and compression, and we have predictive analysis. So using HANA, you can do predictive analysis, and we can have compression, modeling, hybrid, and in-memory. First, we'll take one by one. What is in-memory database? In-memory database, in the sense, it's very simple. If I'm asking you a question, if answer is in your memory, in the sense in your brain, say like I'm asking you a question like where you studied your 10th class, you know it is in your mind, so you're going to reply back from your brain. I'm asking you one more question like where Gandhi studied his matriculation, then you don't know that. So that information, that answer is not in your brain. Then what you do, you're going to search in some other place, say like you are going to search in a book. At in one of the page, you can get that information. You need to go to that page and you need to read through that page. Then only you will get the answer. Then you're going to read and you're going to keep that information temporarily, and you can give the answer. In first case, you can give the answer immediately. The reason is you have information in your mind. So you got the question, immediately you are answering it back. Now we have one more question, but that information is not in your brain. So you looked in some other external or some other device or some other book, and you are getting this information, that book, and you are reading through, and you're just keeping the information in the brain temporarily, and you're going to reply back. So later process, looking at the book is going to take more time, and if you're keeping the information in brain, if it is, then it is going to take lesser time. So the first process is going to take lesser time. That process is nothing but in-memory process. So in-memory process is going to give results more quickly. Now based on this, we have something called in-memory computing. So in general computers, you are going to process the queries using processors, and we have RAM. RAM is read access memory, and we have hard disk. hard disk is going to store the data. So if you want to process something, say like if you want to select the data, then the processor is going to send a query to RAM. RAM is going to interact with HDD, and in HDD you can see the data. So the read and write operator is going to read the data from HDD, and it will write the data back to RAM, and RAM is going to give the results to the processor as a output. So processor is finally going to give the results, which is nothing but output. In order to give the output, the processor has to process the query, and processor is going to interact with RAM. RAM is going to interact with HDD. HDD is going to send the information to RAM, and in turn, the RAM is going to send the information to the processor. This is the way normal computer works whenever you try to retrieve the data from the computer. We have three devices: processor to process your queries, and RAM, it's a volatile memory, and which is useful for reading purpose, and it is going to read the data from HDD, and it is going to finally send the data to the processor. So this is the way it works. Now we have something called in-memory computing. In-memory computing in the sense we are not going to use HDD, and we are going to use RAM for storing purpose. So what is in-memory computing? In-memory computing in the sense whatever data we are storing in HDD, we are going to replace HDD with RAM itself. So it is going to access the data as well as it is going to keep the data within it. So if you start keeping the data in your brain, then obviously you can give the answers quickly. In similar fashion, if you are trying to process a query, and if you have the data in nearest storage location, that is nothing but RAM, then no need to perform additional steps, these two additional steps. And HDD technology is a kind of older technology, but still we are using HDD in the sense it's a disk, and while disk is rotating, which is nothing but a spinning, while disk is spinning, the read and write operator is going to read the data and write the data into the disk. It is a kind of an older technology, and in the disk we can have spirals. Whatever data you are looking for, it will be available in different spirals across the disk. And while disk is spinning, the required data we are going to read from the spinning disk. It is a time consuming process, and you can compare like nowadays while playing these songs, you can go to the selective songs. In older days you need to wait until you get the old song, uh, required song. So what I would like to say, we have rigid locations in the RAM, and whatever you want you can get it very easily. And whereas in disk, the disk has to spin, and while spinning you have to read the data. It's an old technology and it's a time consuming technology. Now you can access the data from rigid locations, and we can access and present the data from nearest location without having additional swapping steps. So using in-memory computers, we can avoid additional swapping steps, and we can avoid the old spinning technology. So you have data in the nearest location and you can retrieve the data very quickly. So finally, what I would like to say, in-memory computing in the sense storing all the data in the RAM and no need to use additional component called HDD. In older days, yes, it is not possible. The reason is RAM cost is very high. Now, because of the innovations, latest innovations, and RAM cost is came down drastically from last 1 decade. So yes, it is possible to create in-memory computers now. So without HDD, we can have computers, and those are nothing but in-memory computing. So SAP took this in-memory computing concept, and SAP created a database. And whenever we use a database called HANA, all the data will be stored in the RAM itself. So because of that reason, it is known as in-memory database. All the data will be stored in the RAM itself. So it is known as in-memory database. So we can avoid spinning and swapping step. So RAM capacities has been increased. Say like I'm talking about, or I'm trying to give answer to Deepika's question. And although the question it doesn't looks to me in a correct fashion, then RAM should be more as compared to the older days. Okay, so I'll try to give answer. So nowadays, the whatever RAM you are going to see in these in-memory computers, these RAM sizes are more in the sense we have RAM sizes in our computers like 4 GB, 4 GB RAM, or 8 GB RAM, or 16 GB RAM you are going to see at max. And HDDs we can have 1 TB. Now we do not have 1 TB HDD here in order to store the data. So what happens? We are going to see 1 TB RAMs. So in order to store the data, in order to access the data, in order to send the result to the processors, we are going to use 1 TB RAMs. So in-memory computers, especially in HANA instances, you are going to see minimum 1 TB RAMs, and it could be more than that. In certain instances, you can see 2 RAMs, 2 TB RAMs, and you can have up to 56 TB. So 56 TB in the sense it's somewhere around near 56,000 GB. You can imagine what happens to your performance once you started using a RAM with 56,000 GB. We are talking about 16 GB. Now I am talking about 56,000 GB. So obviously the performance will be get improved, and because of in-memory technology like the additional swapping steps, spinning steps we can avoid, right? Because of those reasons also the performance will be get increased. So am I good with the answer, or do you have any further questions, Deepika? Now we started with one of the feature and main feature in HANA. HANA is an in-memory database, and this in-memory database is going to give quicker results in the sense if you start storing the data in this database and if you start processing the data, then the processing can be get executed quickly. So that is use of in-memory database. In-memory database in the sense all the data will be stored in component called RAM. RAM in the sense it's a read access memory. It's an in-memory component. Now let me discuss about the HANA definition, and later on I'm going to discuss about all these concepts. So HANA is an in-memory database. And what is HANA and how this in-memory database is useful? Now let's discuss about what is HANA. In HANA, H stands for high performance and AN stands for analytical and A stands for appliance. So this is your HANA definition. H high performance, AN analytical, and A in the sense appliance. This is your HANA. So HANA is going to get the high performance because of, just now I told, because of in-memory computing concept. So we are going to use high-end RAMs and we are going to store the data in nearest storage location. So in HANA, obviously, we are going to see high performance. And appliance. What is this appliance? Appliance in the sense, it's very simple. Whenever we use software and hardware, whenever we use software and hardware in a combination, then I'm going to call that one as appliance. We have home appliances, microwave and washing machine. These comes under home appliances. If you look at the washing machine, you have options like you can skim the drum for say like 30 minutes, or you can rotate the drum within the washing machine for 30 minutes. It is possible by passing the instructions. In order to pass the instructions, obviously we have a panel on top of the washing machine. So using that panel, which is a circuit board and where the software is embedded, and you can have instructions like rotate for 30 minutes. So you are passing the instructions using software and you are making the hardware to work based on your instructions. So washing machine is a home appliance where you can see the combination of software and hardware. You have micro oven, and the micro oven is again, it's a appliance, and there also you can see software. Using that software only you can start giving the instructions like heat the food for 30 seconds or 1 minute. And we have ATM machines. ATM machines also comes under appliances where you have a computer and computer will have software within it, and we are going to use that and we are going to do the transactions. If you want to withdraw 5,000 money, then finally the hardware component is going to give a 5,000, but the instructions we pass through software. So whenever we see a hardware is embedded with the software, then I'm going to call that one as appliance. Why I am calling HANA as a appliance? Last E stands for appliance. HANA is a database. Database in the sense, no doubt, it is a software. HANA is a database. It's a software, and this particular software was created in 2008 using a programming language called CPP, C++. And they created this software as a in-memory database. So this particular database is going to hold the data, and we would like to store the data in the in-memory in the sense in the RAM itself. So if you want to install HANA, it's appliance. It's basically it's a database, so it's a software, but this software has to be installed in a specific device where you can see high-end RAM. You cannot install HANA where you have 16 GB or 32 GB. So we required more capacity with respect to hardware. So SAP is partnered with few vendors, hardware vendors, and we have Cisco, Fujitsu, Dell, HP, IBM. All these people are hardware vendors, and SAP is asking specially manufactured computers or CPUs or instances servers so that HANA can be installed on it. So these hardware vendors are going to create the hardware, and as a company owner, what you need to do according to your requirements, first you need to choose the hardware. The reason is you have business data. You are going to store that business data in HANA DB. HANA DB is going to use the RAM to store the data. It's a hardware component. So because of that reason, we have to choose a specific hardware where we can see high-end RAMs. So we need to have at least 1 TB RAM in order to store the business data. So 1 TB RAM, it has to be created or it has to be manufactured by the hardware vendors. So HANA installation, it should happen in a combination. And if you want to install HANA, then you need to buy appropriate hardware from the hardware vendors based on the data sizing. So you need to do, first of all, data sizing, and based on your company's data, you need to go ahead with corresponding hardware. Once you purchase the hardware, then you can have software from SAP and you can start installing that software in the specific hardware. So in order to install HANA, you required a specific hardware. On top of it only, you can start installing the software. So it should go hand in hand. Because of that reason, it is known as an appliance. So HANA is an appliance. Being a database, it's a software, but this software has to be installed in a specific hardware. So without specific hardware, you cannot install. So for that reason, it is known as an appliance. So if I want to install HANA in my office premises, then first of all, I need to get appropriate hardware from IBM. And in that system only, I can start installing HANA. So it goes something like this. We are going to finalize the size of the RAM by doing data sizing. And once we have purchased CPU or set up CPU, with high-end RAMs and multi-core processors. Then within the CPU, obviously we need to have, first of all, OS to be installed in order to run the instance. So we have SUSE Linux. This is operating system, and every HANA instance is going to use this operating system only. And once operating system is available, then on top of it, we are going to see HANA DB. So this is your hardware component, and this is OS, and on top of it, we have hardware, we have HANA DB. So this is your appliance, specific hardware, and within that, in memory, a database. So appliance in the sense it is combination of hardware and the software. Now this particular appliance is a high performance appliance. We know in washing machines itself we have high performance and low performance. High performance in the sense a drum will be rotate quickly when compared to low performance one. And we have high performance and low performance. We can compare in our lights also. You can see high performance and low performance. Like you have 250cc bike and 500cc bike. Obviously 500cc bike is more powerful than 250. And you have Swift car and bench car. Bench car is more powerful than Swift car. And performance wise, RPM wise, CC wise, bench is more powerful than Swift. And we have something called bus and airbus. Airbus is more powerful than bus. So we have high performance and we have low performances. And HANA is high performance appliance. And for HANA, the high performance comes from the hardware as well as software. So hardware in the sense it is going to use multi-core processors and high-end RAMs. And because of this reason, we can have high performance. Not only that, we are going to store the data in memory. So we have columnar storage and in-memory storage. And because of all these reasons, we can get more performance also. So we have a lot of reasons for the performance, and I'm going to discuss those reasons later on. But finally, what I would like to say, HANA is an appliance, and it is a high performance appliance and basically useful for analytical purpose. So this is your HANA. HANA is high performance appliance which is useful for analytical purpose. So what is meaning of analytical? Analytical in the sense, again I can split this one into two words. One is analysis and the second one is analytics. Analysis in the sense, if you want to know what happened, then that is nothing but analysis. Analytics in the sense, if you want to know what is going to happen. So this is nothing but your analytics and this is nothing but your analysis. If you want to know what was happened to your business and what is happening to your business, then you have to do analysis. And if you want to know what is going to happen and if you want to do kind of a risk analysis, risk analytics, and if you want to do kind of a predictive analytics, then that is nothing but what is going to happen. So what is going to happen comes under analytics, and what was happened comes under analysis. So using HANA, you can do both. So HANA is a database, and all history, business transactional history will be available here, and we can hit that database and we can do what was happened. That is nothing but analysis. And HANA is a database. You can have a sample data, and you can take the sample data from the database, and you can create algorithm, and using this algorithm, what you can do, you can apply this algorithm on the sample data, and you are going to get predictive results. And by analyzing those predictive results, you'll come to know what is going to happen. So using HANA, finally, what I would like to say, you can do the analysis and you can do the predictions. Doing analysis and predictions is nothing but analytics or analyticals. Now, HANA is a high performance appliance which is useful for doing analysis as well as the predictions. So we are going to use HANA in order to store the data, in order to do the reporting on top of it, and certain reports it is going to give the historical data analysis. Certain reports are going to give a kind of the predictive information also. So finally, what I would like to say, you can use HANA as a data analytical solution as well as a data science solution also. If you start doing the predictions, then that is known as data science, and we can do even the data science also using HANA. So HANA is high performance appliance which is useful for analysis as well as the predictions. Now this is a definition of HANA, and in our first session we discussed about the definition of HANA, and we discussed about what is HANA DB, what is in-memory database, and what is in-memory computing. So let me know if you have any questions till this point. Okay, then I would like to discuss about how we are going to get high performance. As I already discussed, we are going to use high-end RAMs. This is one of the reason we are going to get high performance. And the second reason is we have in-memory computing, so we can avoid spinning and swapping steps. And this is also other reason to get high performance. Now, why we do get high performance? First reason, high-end RAMs, and second reason, we can avoid swapping and spinning steps. And next, if you are going to use multi-core processors, we need to understand what is this multi-core processor. We are going to opt for a hardware, especially in HANA, and where in that CPU or in that hardware, you are going to see multi-core CPU, multi-core processors. Now, we have something called processor. Processor looks something like this. In this processor, you can see cores within it. And while taking the computers, you may look for processor, correct? Generally, we have Intel processors like i3, i7, all these are Intel processors. i3, i5, i7. So we already know i7 is powerful processor than i5. i5 is powerful processor than i3. So what is the difference between, the main difference between i3, i5, i7 is number of cores within it. So you might have heard about dual core. Dual core in the sense we have two cores within it. And we have something called quad core. Quad core in the sense we have four cores within it. This is nothing but your quad core. Dual core, quad core processors. And we have octa core. Octa core in the sense we have 8 cores within it. So i7 in the sense it's an octa-core processor where you're going to see 8 processors within it. And i5 will have 6 and i3 will have 4. So when cores are increasing, then the performance of processor will be getting increased. So i3 is having less cores, i5 is having more cores than i3, and i7 is having totally 8 cores. So cores are going to act as workers. If you are increasing the workers and if you are asking them to work in parallel, then you can start completing your work quickly. So we have something called parallel processing, and parallel processing is possible in your processors whenever you increase the cores. So processor is going to take the work, which is nothing but instruction. So this work has to be done within the processor. And if you have multiple cores within the processor, then because of the parallel processing, it can be done quickly. So SAP HANA hardware will have multiple processors, and within the multiple processors, you can see multiple cores. Because of that reason, we can complete our processing jobs. It could be data processing, it could be completed quickly. Say like if you are trying to read millions of records from the database table, that is nothing but reading the data from the database table is nothing but data processing. That can be done quickly in HANA. So how your HANA looks. How your HANA hardware looks. Now, if you have a multi-node CPU, then we have something called rack systems. In these rack systems, you can have multiple motherboards. Normally in your CPUs, you can see one single motherboard. You can have multiple motherboards, and you can have processor. So if you open your laptop or if you open your CPU, then you are going to see a single motherboard, and on a single motherboard you can see single processor. But we are going to use a kind of CPUs where you can see multiple motherboards and multiple processor multiple processors on each motherboard, and within these motherboards within these processors, and you can see multiple cores. I'm just keeping the cores now. Okay, now if you are using a computer with dual core processors, then in your computer you have two cores to work on different activities. Now imagine a system, a hardware system, where we have, say, like 4 motherboards, and on every motherboard, say like you have 8 processors, and I mentioned here 4 processors. Okay, say you have 8 processors on every motherboard, and in every processor you have, say, 10 cores. 4 motherboards, on every motherboard you have 8 processors, and every processor you have 10 cores. Then what happened? Finally, if you multiply, you have a system with 320 cores. Imagine a hardware component with 320 cores, and if it is using high-end RAM, then what happens to the performance? You are using in your computers maximum 4 GB to 8 GB RAM, and you are using 4 core or 6 core or 8 core processors. Imagine you have 320 core and 1 TB RAM, then what happens to the performance? So SAP HANA systems are going to use these kind of infrastructures, multi-processors or multi-core processors, and using these multi-core parallel processing, you can handle huge volumes of data, and you can process huge volumes of data, and you can do a kind of a partitioning, and the database partitioning data can be given to different cores, and you can perform parallel processing. So HANA is a high performance system. The reason behind it, we have high-end RAMs, and we have multi-core processing components, and we can avoid swapping and spinning steps. So because of all these reasons, we have high performance. Not only this, we have other reasons also. I'm going to discuss about the other reasons like hybrid DB, columnar storage, as well as row storage, and because of the compression. So there are certain reasons to improve the performance of HANA system. So it's a high performance appliance, and if you want to process huge amount of data, millions of data, And if you want to process millions of data in seconds, then it is possible through SAP HANA. If you want to read millions of records, and if you want to process millions of records in one shot, then it is possible through this analytical appliance. So for that reason, it is known as high performance analytical appliance. Okay, so I'm done with your first session, and I discussed about in-memory database, and then I discussed about HANA definition, then how HANA is going to get high performance from the hardware. I discussed about that. So next 5 minutes, I'll leave it for you. If you have any questions, please let me know so that I'll try to give answers. And I recorded this session and I'm going to share with you. And tomorrow and day after tomorrow also we have sessions on HANA. So if you do not have any questions, you can start leaving the session, so that once everyone left the session, then I'll close the session. If you do not have any questions, then you can start leaving the session by closing the window. And I can assume like you do not have any questions. Once everyone left, then I'm going to close the session.